Welcome to our Cryptography Fundamentals Hybrid Cryptography module. Today we use mostly hybrid cryptography, which is a combination of symmetric and asymmetric encryption. Usually this process starts with an asymmetric key exchange where a random session key is generated by one of the parties in the communication, that is going to be the individual who initiates the communication. They use the public key of the person that they want to communicate with, and they encrypt a one-time session key using that recipient's public key. Now that the session key is encrypted, it can be securely transmitted without a worry of someone intercepting it and being able to decrypt any subsequent communications. Once the recipient receives the encrypted data, they can decrypt it with their private key, and they now have access to the symmetric encryption key that the sender was trying to share with them. They will then send an encrypted verification message in order to confirm that they received the correct key, and this is encrypted using that symmetric key and very fast AES algorithm. Once that verification message gets back to the original sender, they will decrypt it, and if they're able to successfully decrypt it, they know that this process worked correctly, and they can now use symmetric encryption to secure the data that they are going to transmit before sending it to each other using that shared session key that they were able to exchange using asymmetric encryption. Once they're finished exchanging their data for this session, they will discard that session key and they will not use it again. If they're going to communicate again, they will start this process from the beginning with a new key exchange. Here we have a visual of how hybrid cryptography functions. In this example, the sender would like to send a large amount of data to the recipient, so therefore asymmetric cryptography would not be appropriate because of its high overhead and its lack of speed. So the sender decides that they will use symmetric encryption, but they do not have an easy way of getting the key to the recipient, so they'll use asymmetric encryption to transmit the key. So the sender will generate a 128-bit key, which will be used later for the symmetric encryption process. They'll encrypt that key with the recipient's public key, which is widely available, and the recipient can share that with anyone they please. Once they encrypt that data using RSA and the recipient's public key, they are now transmitting encrypted data, which cannot be intercepted by unauthorized individuals. Once that encrypted message gets to the recipient can then use their private key, which only they should have access to decrypt the message that was sent to them by the sender. Once they decrypt the message, they now have access to the 128-bit session key that the sender is going to use to encrypt data using a symmetric algorithm. Now that they both have the same key, which was transmitted securely, they can switch to using symmetric encryption, which is much faster for large amounts of data. This concludes our Cryptography Fundamentals module. Thank you for watching.